Good morning, good day, and good evening to all listeners. My name is Kebone Maselela, and I'm currently an MSc candidate from the University of the Witwatersrand in South Africa. Today, I will be presenting to you my master's project under the topic, the Balk Reef, a Witwatersrand type deposit. The Balk Reef is located in close vicinity to the enigmatic Auriferous and Uraniferous Witwatersrand supergroup. So why bother study the Wits since most of the existing Wits gold mines will be closed by the year 2040, and gold production in South Africa has decreased over the past 3 decades because of energy and labor costs required to reach distal deposits, insufficient room for mechanized mining at kilometer depths, and unsafe working environments for employees at these depths. So the main question under this theme is, how does the Balk Reef Formation contribute to sustainable development? Well, it has similarities to Wits type gold in terms of the style of mineralization, such as having Ocean granite greenstone terrains in the hinterland, abundant iron-bearing phases in the form of pyrite, and abundant carbonaceous material. Therefore, the exploration and exploitation of the Balk Reef Formation would provide an alternative to gold production and further sustain South African development for the future. Taking a deep dive into the area, the Kafel Craton hosts various Archean granite greenstone rocks, and these greenstone belts are overlain by the Dominion Group, Witwatersrand, Ventersdorp, and Transvaal supergroups. Later, emplacement of the Bushveld igneous complex took place, and the Vredefort meteorite impact occurred. The Neo-Archean Balk Reef Formation, in blue here, is a thin and naturally extensive sequence of fluvial siliciclastic rocks at the base of the Transvaal supergroup. The Balk Reef itself is a small to medium-grain quartz pebble conglomerate with deeply scoured channels which eroded into the footwall. The most prominent feature of the Balk Reef is its abundant carbonaceous material in the form of pyrobitumen. It has significant concentrations of gold, uranium, and less PGEs. The most accepted source of gold is from reworked conglomeratic rocks of the upper Witwatersrand reefs and the Ventersdorp contact reefs. In the study area is in the Carltonville Goldfield, where the Carbon Leader Reef, the Middle Flay Reef, the Livingstone Reef, and the Ventersdorp contact reef sub-outcrop against the Balk Reef. In the East Rand, only the Kimberley Reef sub-outcrops against the Balk Reef. The incised Balk Reef channels intersect high-grade Witwatersrand Reef, which raises the potential for high-grade reef horizons through reworked channels. The Balk Reef was also subjected to metamorphism, where low-grade sub-greenschiest metamorphic facies have been recorded. In addition to that, loading of the thick Transvaal sequence, emplacement of the Bushveld igneous complex, and the geological catastrophe of the Vredefort meteorite impact all caused post-depositional metamorphism of the Balk Reef. In this study, 4 drill holes were used to undergo detailed core logging to record characteristics of the mineralized reefs and the overlying and underlying lithology. The simplified lithological logs show that the stratigraphy of the Balk Reef begins with a medium to coarse-grained quartz ironite in the hanging wall, which has gold grades that are less than 2 grams per ton and associated with pyrite grains. The quartz ironite gradually changes to having scattered, sub-rounded quartz pebbles defined as a pebbly quartz ironite, which are characterized by gold concentrations of about 2 to 5 grams per ton and have pyrite grains which are hosted in a carbonaceous matrix. They are integrated with well-packed, matrix-supported conglomerate units. The gold concentration in these units ranges from 5 to 30 grams per ton in some instances, and the quartz pebbles are often embedded in a black carbonaceous matrix with abundant pyrobitumen, which frequently occurs at the bottom contacts. These conglomerate units eventually find down to a carbonaceous shell with rounded pyrite nodules and pyrite orientated as stringers. In places, the carbonaceous shell is intercalated with gold-rich conglomerates, and these carbonaceous shells contain graphite in the matrix. Petrographic analysis was made in these units, and the quartz ironite samples show annealing and compacted quartz grains, and often the pyrite grains are orientated along bedding and cross-bed faucets. And this is indicative of synth sedimentary formation. The carbonaceous shells usually have very fine-grained quartz. Specifically in the sample, there is grain size variation and fracture-filling carbonaceous material. The cubic pyrite grains are also observed, which is indicative of a hydrothermal fluid formation. The conglomerate rocks have fractured quartz pebbles that often contain carbon nodules and fracture-filling carbonaceous material. Areas where there is quartz straining have tiny gold specks within these extensional fractures. The petrography of the ore minerals show that there's various types of pyrite grains which have been classified by formations such as massive detrital pyrite, random inclusion bearing detrital pyrite, concentrically laminated detrital pyrite, the euhedral orthogenic pyrite, and orthogenic pyrite overgrowth. The concentrically laminated detrital pyrites are the most important to distinguish because they consist of concentric sets of laminae, often with inclusions of gold in the interstices. Another important feature is that they are fractured, and this shows that they did not form in the Balk Reef, but were rather transported from a sedimentary precursor with their preserved internal structure indicating a short travel distance from their source while carrying trace elements and gold between their laminae. The carbonaceous material also occur in four main subtypes based on morphology, such as fracture filling, mostly in shales, globular, which often contain the most irregular shaped and micron-sized gold and uranium minerals, nodular, which are relatively smaller and rounded, and irregular shaped, which occur mostly within the boundaries of pyrite. And lastly, the gold, where gold occurs as native gold along quartz microfractures and at pyrite grain boundaries. Fluid inclusion microthermometry in this analysis revealed that there are four main types of fluid inclusions at room temperature. That is two-phase fluid inclusions where the liquid is dominant, two-phase inclusions where the vapor is dominant, monophase inclusions with only a liquid phase, and three-phase liquid vapor inclusions where carbon dioxide is dominant. The average homogenization temperature or trapping temperature is 172 degrees Celsius, and the average freezing point temperature is -5 degrees Celsius. The salinity was calculated to be 7.04 weight% sodium chloride equivalent, and the density was estimated to 0.948 grams per cubic centimeters. Raman spectroscopy also was used to define the concentration of the fluid inclusions, and the concentrations that were observed were H2O carbon dioxide, H2O carbon dioxide methane, H2O hydrogen sulfide, and methane inclusions, and these are very important in the later sections. Geochemistry reveals that the Balk Reef sediments are related to their protosource. So that means that Archean felsic rocks of the Kapval Craton in the hinterland are the protosource rocks of the quartz ironite and conglomerate sediments of the Balk Reef based on their correlation with zirconium, whereas the Archean mafic rocks of the Kapval Craton in the hinterland are the protosource rocks for shale sediments of the Balk Reef based on elevated nickel and chromium content and the high magnesium number. The mean whole rock delta 34 sulfur values of the study coincide with values obtained in the VCR and the Carltonville, Velcom, and Klerksdorp gold fields from studies by Hoffman et al. 2009 and Guy et al. 2014. Therefore, the source of pyrite is the underlying strata of the Black Reef, and by inference, this provides evidence that the gold and the sediments in the Black Reef are mechanically sourced from the VCR and the Wits reefs. So how does all this data tie in together to form a metallogenic model for gold mineralization in the Black Reef? Well, the sediments of the Black Reef are derived from a protozoa such as the Archean granite greenstone belt in the hinterland, and the sediments were deposited into the Wits and the Ventersdorp subgroups, where they were subsequently reworked and recycled into the Transvaal Basin. So due to mass balance calculations that were outlined by Frimmel et al. 2005 and 2015, they show that the greenstone hosted orogenic gold sources in the hinterland could not produce all the gold content that is found in the Witwatersrand reefs for a purely sedimentary genetic model. So a more likely source is the entire Meso-Archean land surface of the whole Kappa Craton envisaged by Nwala et al. 2020. This land surface contained background concentration of gold. So in an anoxic environment with CO2 degassing from high volcanic activity, acid rain formed and caused chemical weathering, which leached out gold from its precursor host and transported gold as a dissolved species in meteoric water. The gold was precipitated out of solution by oxidation when the fluids were in contact with photosynthetic cyanobacteria, seen as the microbial mats. This is the reason why the Kebone Leader Reef has the highest gold content in the Carletonville goldfield, gold that is associated with carbon seams. Further physical reworking of these delicate microbial mats formed fine-grained gold that was redeposited as paleoplaces in the Wits reefs and later into the Ventersdorp contact reef. It is therefore critical to emphasize that the primary mechanical processes followed by hydrothermal activity led to gold mineralization in the Black Reef. The mineralizing fluids are derived from devolatilization and dehydration reactions during diagenesis and emplacement of the Bushveld igneous complex, and therefore the fluids are sourced from a metamorphic and meteoric water mixing. The carbonaceous material in the Black Reef Formation is described as residues of migrating hydrocarbons generated by thermal maturation of organic matter through the oil window, which are temperatures reached through the fluid inclusion analyses of 172 degrees Celsius. The source of the carbon could thus be the shell units in the Volkberg group or the shallow marine carbonates in the Tunispoort group of the Transvaal Basin. And therefore, these are internally derived hydrocarbon fluids. Gold was transported as a bisulfide complex once it was dissolved. The presence of H2S in the fluid inclusions is known to assist in dissolving gold, while this carbon dioxide in the fluid inclusion is said to assist to keep the gold in solution. The geological catastrophe of the Vredefort meteorite impact caused secondary permeability and reactivation of pre-existing structures, which allowed hydrocarbon migration and remobilization of fluids, which have been circulating in the basement due to the Bushveld igneous complex, and this carried gold and other ore constituents. The erosional and angular unconformities also play a major role in directing the flow of fluids, which accounts for elevated gold concentrations at areas where the Black Reef is in contact with the Wits and the VCR. So based on Le Chatelier's principle, the precipitation of gold in this equation will be caused by the decrease in hydrogen sulfide species and the decrease in oxygen fugacity or an increase in pH. The reaction of gold-bearing fluids with iron-bearing minerals depleted the sulfide in solution by forming pyrite or pyrrhotite and decreased the gold solubility. The interaction of fluids with carbonaceous metasediments also lowers the oxygen fugacity. This accounts for all the native gold found in close proximity to pyrites, and irregular shaped carbon nodules. This shows that the main precipitation mechanism in the Black Reef is precipitation by reduction. And another gold trap in the Black Reef is the quartz microfractures, indicating that there was free gold. Thank you for your attention.